Okay, the last step in this process then is to determine what we call a molecular formula. So if you go back to the very beginning, what we first started talking about was the molar mass of elements, and then we talked about the molar mass of compounds. From there, we were able to do conversions, and then from there, what we started looking at was what we call percent composition. Once you know the percent composition of a compound, you can develop what we call the empirical formula, which is the lowest whole number ratio of elements in that compound. Well, with a little bit more data, what you can do then is calculate what we call the molecular formula. So if you were to use something like a mass spectrometer, which we talked about earlier in determining masses of elements, you can also use that mass spectrometer to determine the mass of a compound. From that, you can calculate what we call the molecular formula. The difference between an empirical formula and a molecular formula is pretty simple. The empirical formula tells you the simplest whole number ratio of elements in the compound. So for example, you might determine that the empirical formula is CH. That doesn't tell you what the formula of the compound is, it just tells you the smallest whole number ratio. The molecular formula will tell you exactly what's in the compound. In other words, the actual formula of the compound. So the ratio might be 1 to 1, but there might be 6 carbons, 1, 2, 3, 4, 5, 6, and 6 hydrogens present in that compound, something like that. So the molecular formula tells you what's actually in the compound. The empirical formula tells you the smallest whole number ratio. So let's go through the process of how to determine the molecular formula. Okay, the first step in this process is the same process or the same procedure that we did determining the empirical formula. So you might be given moles, you might be given grams, or you might be given percentages. So if you're given percentages, the first thing you want to do is assume we have a 100 gram sample. That way we can say we have 49.3 grams of carbon, 6.9 grams of hydrogen, and 43.8 grams of oxygen. Again, we did that when we discussed how you determine the empirical formula. So if you remember, the first step is to convert to moles. So let's do that. 12 grams of carbon per mole of carbon, 1 gram of hydrogen per mole of hydrogen. And if you're unsure about these conversions, you want to go back and practice these until these are second nature. At this point, if I said convert from grams to moles, you should automatically know that there's 16 grams of oxygen in 1 mole of oxygen. Now I do want to point out something here. We talked about oxygen being written as O2. When oxygen is part of a formula for a compound, though, we just leave it as O until we figure out what that subscript is going to be. Okay, so let's finish the conversions here. We've got 49.3 divided by 12 gives us 4.11, or we could just say 4.1 moles of carbon, 6.9 moles of hydrogen, and 2.7 moles of oxygen. Now remember, we want to divide by the smallest of the three, so we're going to divide them all by 2.7, 2.7, and 2.7. So we're going to get 1 mole of oxygen, 2.5 moles of hydrogen, and 1.5 moles of carbon. So then what we need to do is figure out, since these aren't whole numbers here, we need to figure out what factor to multiply these all by. So you can see if we multiply by a factor of 2, we'll get 3 moles of carbon 5 moles of hydrogen and 2 moles of oxygen. So now we know that our empirical formula is C3H5O2. So now to figure out what the molecular formula is, there's 3 steps. The first step is figure out the molar mass of the empirical formula. So 3 times 12 plus 5 plus 2 times 16 gives us 73 grams per mole. And then what we want to do is take the given molar mass of the molecular formula. Now that value has to be given. If it's not, there would be no way to figure out what the molecular formula is. So you take that molar mass, divide by the molar mass of the empirical formula, and you're going to get a whole number factor. That factor, then, you simply multiply all the subscripts in the empirical formula, and that'll tell you the molecular formula. So C6H10O4 would be the molecular formula. If you want to double check that, add up the molar mass of that, and it should equal 146. So if we check our answer, we can see that's our empirical formula, and that is our molecular formula. Okay, let's do one more example problem. We have 48.6% carbon, 8.1% hydrogen, and 43.2% oxygen. So again, write them in grams first. So 48.6 grams of carbon, 8.1 grams of hydrogen, and 43.2 grams of oxygen. Convert to moles. 12 grams of carbon per mole, 1 gram of hydrogen per mole, and 16 grams of oxygen per mole. Do the math. 48.6 divided by 12 gives us 4.05. So 4.05 moles of carbon, 8.1 moles of hydrogen, and 2.7 moles of oxygen. Divide them all by the smallest, 2.7, 2.7, 2.7. We get 1 mole of oxygen, 3 moles of hydrogen, and 1.5 moles of carbon. Now what you don't want to do is round very much here, because you don't want to look at that and say, oh, that's about 4 and that's about 2, because obviously they're not. So make sure that you leave enough significant figures that you don't have to round that much. Alright, that's not a whole number, so we need to multiply everything by a common factor to make that a whole number. So as you can see, we're going to multiply by 2. So we get 3 moles of carbon, 6 moles of hydrogen, and 2 moles of oxygen. So our empirical formula will be C3H6O2. Add up the molar mass of our empirical formula. 3 times 12 plus 6 plus 32 equals 74 grams per mole. The molar mass of the molecular formula is 296, so we're going to take 296 divided by 74, and we get 4. So our molecular formula is going to be C12H24O8. So as you can see, calculating the molecular formula is not much different than calculating the empirical formula. You're just adding this final step at the top.